Alright, moving on to number 16, centroid formed by medians. Well, this one's a real easy one to get, and it's shown up on the exam enough where it's good to make it one of my 20 topics. Now these segments here in blue are medians. Medians connect each angle or each vertice of the triangle to the midpoint on the opposite side. So all of these points here are midpoints. That's what medians do, is medians create midpoints. If you join all three medians together in a triangle, the answer will always appear inside the triangle, and it will divide these segments into pieces such that one piece is twice as big as the other. So let me illustrate by doing this question. They're telling me that from T to B is worth 9. So that whole segment's worth 9. If that whole segment's worth 9, the smaller part is always half as big as the larger part. So you'd have to just set up the simple equation that together the 2x plus the x is equal to 9. Why does it work that way? I would imagine it has something to do with similar triangles. The exact reason is not important for this course, the old style Regents exam, but might be important next year when we do the Common Core. So x would have to be worth 3. And if you stop there, you get the question wrong. They want to know the length of TD. So even though it's 8 o'clock in the morning and I'm outside on a Sunday morning drinking my coffee, doing this video, I still caught that possible mistake that you could make. Is at the end they want to know what TD was worth. TD would have to be worth 2 times 3, or 6. Alright, here are some other vocabulary phrases that the exam is expecting you to be familiar with. Of all of these, in my opinion, the most important one is probably the centroid. It's shown, in my eyes, has shown up the most. But, you know, there are some other pictures that may look like the centroid, but are not. And it's important to make sure that you are aware that there are different vocabulary words associated with different situations. The incenter is the one I'm going to show you right now. The incenter is where the angle bisectors all match up. And doesn't it look like these two pictures are exactly the same? Well, this is where the medians are all intersecting in the centroid. These are not medians here, these are angle bisectors. And when the angle bisectors all agree, we create something called the incenter. So let's take a look at this picture here. So this is not like the first one. This is talking about the angle bisectors being drawn. So let's pay attention to exactly what they're telling me. They're telling me that AE bisects angle CAB. So I know these two angles are the same. They're also telling me that CD splits angle BCA into 2 equal pieces. Now, this is an example of the incenter, and it's not something that's completely shocking to you, but you know, it's in terms of it's not that radical of an idea, but the idea is if we got 2 angle bisectors that are intersecting each other inside the circle, then if we draw another segment to that point is called the incenter, and that would make this last one also an angle bisector, where these 2 angles would have to be the same. So that is what they're reaching for on this one, is that choice 4 happens to be true. The 3 angle bisectors of a triangle will always intersect at the same point. So that is the correct choice. If you looked at the other choices and see if are there any other choices there that look tempting to do just by looks alone, do you think that DG is exactly the same as EG? Well, I put a little question mark there. In this particular case, I believe that DG looks much smaller than EG. So I would say that's not true, just based on looks alone. How about AG being the same as BG? Well, hey, the Bee Gees. It's a band, right? Okay, so AG, to me, AG looks much smaller than BG. So I would say just on looks alone that that's not correct. And it brings me down to the last two choices. Just by looks alone, angle AEB. AEB. Well, that's an acute angle right there. Yeah, black angle right there. Is that the same as AEC? Well, that's obviously false. The dark angle is an acute angle, and the white angle here with the dots is obtuse, so those can't be the same. So here's a question that you can get right if you just study the picture and hack at it and find out which ones look right and which ones don't look right. So use the choices to your advantage, and that's a very good skill to have on these multiple choice sections.